Welcome to Spring LIB.
All right, so we have an aqueous solution of sodium hydroxide in which the molarity is 4.37 moles and the density is 1.1655 grams per mole. And we need to find the weight percent or the mass percent. Okay, if you recall, the formula for mass percent is the grams of our solute, which in this case is our sodium hydroxide, divided by the grams of our sodium hydroxide and the grams of our solvent, which in this case is water, H2O. Okay. Now, the easiest way to go about this is to just assume that we have 1,000 milliliters or 1 liter of solution. And the reason for that is that we can calculate how many grams of sodium hydroxide we would have in 1,000 mils. And as long as we also calculate how much water we would have in 1,000 mils, the 1,000 mil factor will divide out. And actually the total volume of our solution, which we're assuming to be 1 liter, won't affect our answer, which means that, it's sort of an arbitrary choice. We could choose 2 liters or 4 liters or half a liter. It won't change anything. So we're just going to assume that we have 1 liter and then say, well, how many grams of sodium hydroxide do we have if we had 1 liter, and how many grams of water do we have if we have 1 liter? So sodium hydroxide is not too bad because we're told the molarity of the solution, and if you recall, 4.374 moles per liter. That's what molarity means. And if we assume we have 1 liter, then that means we're assuming we have 4.37 moles sodium hydroxide. And if we know moles of sodium hydroxide, we can get mass of sodium hydroxide using the molecular weight, right? Molecular weights are in grams per mole, so we simply take our 4.37 moles and multiply it by the molecular weight of sodium hydroxide, which you can calculate using the periodic table or just look it up. However, you're expected to do that. The answer is 39.997 grams per mole. So the moles will cancel, be left with grams. 39.997 times 4.37. Calculator. And I get 174.8 grams of sodium hydroxide. Okay, finally, I just need to figure out how many grams of water that I have. And the way that we're going to do that is we're going to say that the grams sodium hydroxide we have plus the grams water we have is going to equal the grams of total of our total system, right? Or our solution. That means, whatever's in our beaker, that solution that has sodium hydroxide dissolved in water, it's got to add up to the mass of the sodium hydroxide in the water. There shouldn't be any extra mass coming from anywhere. Now, we know grams sodium hydroxide, and we can calculate grams of solution rather easily if we assume that we have 1 liter, because they gave us the density, right? And that's grams per milliliter. Okay. So we can solve this equation. We can say grams water equals grams solution minus grams sodium hydroxide. Basically, that's how we go about that. So grams of solution, that's just the density of our solution times our volume, 1,000 milliliters. Right, so that's 1,001 or 1.1655 grams per mil times our 1,000 milliliters. It's going to give us 1,165.5 grams of solution. Okay. And so we said our grams of water is just going to be grams of solution minus grams of sodium hydroxide. We already calculated grams of sodium hydroxide, so grams water equals 1,165.5 grams minus 174.8 grams. 1,165.5 minus 174.8. We get 990.7 grams. 990.7 grams. So now we have grams of water, and given our formula, we should be good to go. We can plug all of this in. We'll get grams of sodium hydroxide is 174.8. Okay, down below we have 174.8 plus 990.7. These are all grams. And 174.8 plus 170, or divided by, I should say, 174.8 plus 990.7. It's going to be 0.1499 8. And if we want to put this in a percent, we need to multiply it by 100. Sorry, this is the wrong formula. Well, it's the right formula, but it's the wrong symbol. We're talking about weight percent. So we need to multiply by 100. Weight percent times 100 equals, so we'll get 14.99%.